Hello everyone, my name is Han Xiaotan and I come from Lamar Institute. Today it is my honor to present our work, Visualizing Global Explanations of Point Cloud Deep Neural Networks. The main purpose of this work is to fill the gap of the explainability for point cloud models. A global explainability approach is proposed that generates instances representative of the entire dataset in the model, which is different from the local explanation that focuses on a particular prediction. Commonly used global explanations are, for example, rule extraction and AM, but AM is more applicable to vision tasks, which visualizes representative examples. The basic idea of AM is to select a neuron in the network and maximize the value of it by optimizing the input vector such that the explanation can be regarded as a representation of the chosen class. Existing studies improve perceptibility by adding regularization to images. However, this is not applicable to point clouds, since many regularizations rely on the neighboring correlations between pixels, but point clouds have the property of being disordered. We introduce generative models, an autoencoder to learn the distribution of point cloud instances in order to regularize the generated explanations. Besides, a few variants are added to the raw autoencoder to improve the quality of the explanations. AE is a pure autoencoder based on chamfer distance. AED incorporates a discriminator and latent distance regularization, and NAED introduces additional noises during training. This is a qualitative result. The AM explanations based on generative models significantly better than traditional regularization methods. Diversity is also one of the criteria for the quality of explanations. It can be clearly seen that NAED outperforms other methods both in terms of stability and diversity due to the introduction of noisy training. In order to quantitatively evaluate point cloud AM instances, we propose a new evaluation metric. As a global explanation, there are mainly three elements to be evaluated, namely the value of target activation, diversity, and perceptibility. The proposed evaluation method can take into account all three factors at the same time, and the score tends to be close to human judgments. Here is the results of the quantitative evaluations on proposed AM methods, taking into account the three factors mentioned above, showing that NAED is the best point cloud AM method yet, which is superior in terms of diversity and stability. Here are the references, and we appreciate your attention.